Welcome to my presentation, and this is my assignment 3 task. Today I will show in the assignment 3, I will simulate incident dynamically and reroute vehicle to alternative route using Traci. I use detectors to identify the incident through occupancy level and also reroute the vehicle accordingly. And I actually consider two scenarios. One is baseline scenario and another one is using route assignment, using dynamic route assignment. So in the outline of my uh, project, firstly I describe the project and uh, tell about the objectives, then explain the scenarios in SUMO. In the third step, I will discuss about the detector location, that the position where I set the detectors and also the way detectors reroute the vehicles. And in the fourth stage, I will talk about Traci code. I will show the pseudocode and the chart flow diagrams. And lastly, I do comparative study between the baseline scenario and using dynamic rerouting and find out that the dynamic rerouting is more advantageous under the incident scenarios. So let's come with the project objectives. The primary objective of this project is to use Traci, that is traffic control interface, that is a library in Python. It will simulate dynamic traffic incident, such as the incident can occur due to sudden breakdown of vehicles or maybe got fire or the vehicle is out of order. In that case, vehicle temporarily block the road segment. And this is the scenario I generate using Traci. And the detector, that is induction loop detector, will identify the scenario in real time and it will trigger command of rerouting so that all vehicle will uh, divert to alternative routes and ensure smooth traffic flow. So this is the SUMO model that I developed in NetEdit. There is actually uh, one route A, that is main line or main route, and there is an alternative route, that is route B, that will read out alternative route and it will activate only when incident will trigger and it will detected by the detectors. And detector location, I use induction loop detectors E1, that is installed in each lanes of the affected upstream edge of the affected road. And also it is located just before the entry point of alternative route. Otherwise, it's not possible for vehicle to uh, take the decision to go to the alternative route. The detectors continuously monitor traffic and also detect the congestion. And the condition I use here is occupancy level. If occupancy level in the detector fall beyond 50%, in that case, that will predict some obstruction and reduce traffic flow in the downstream. So in response to that, the detector will dynamically trigger out rerouting command so that vehicle will follow the route B. We can see that the route B in that case. And it causes reduced delay. It minimizes the delay. So this is the sumo config file where I assign the induction loop detectors and loop detectors E1. There are two detectors in the two lanes. Detectors are located upstream of the incident edge, that is E1. I'm showing in the middle portion of my model. And also it is just located a little bit upstream of my alternative route. And this detector will detect or identify automatically the incident and trigger the routing commands. And there are two scenarios. That is scenario one, where vehicle are where there is no rerouting, though there is an incident, but no vehicle will take route. And scenario B, that is rerouting of vehicle will trigger dynamically during incident through loop detectors. So scenario B is our target. Scenario A is our baseline scenario. So we can see scenario A where rerouting vehicle during incident. We can see that in the front of the platoon, there is a vehicle which is getting almost stop or slow moving, and all vehicle platoon behind and queue behind those breakdown vehicle or out of order vehicle, because in this case no rerouting is assigned and all vehicles are moving and traffic are moving in the route A during incident. In scenario two, we can see that we have breakdown vehicle or vehicle which is stopped due to some incident. In this scenario, the detectors are triggered. They can identify the incident and reroute all other vehicles in the route. We can see some rerouting vehicle in the alternative route. So before Traci command, let's go to our simulation so that we can see the whole project. So let's go to the runner 2. Firstly, we will see that our detour routing is true. That is, detour routing is activated. That is scenario B. We'll see first the scenario B. Let's run without debugging. Let's run the we're running that Traci. To make it little bit Python debugging. And our SUMO CSG file is open. Now make delay little bit slower, 50 seconds. Now run the scenario simulation. We can see that the vehicle are moving in the route A. However, when the incident occur, we can see that the detector will activate and it will trigger the vehicle to the dynamically vehicle to the route B. This is still in the regular situation. No incident is happened. We are waiting for the incident. We can see that the incident happened. There is a breakdown vehicle and all vehicle are rerouting in the other direction. And is still the vehicle is rerouting because and it's cleared. After clearing the incident, vehicle are again moving in the original route. And that's all about the scenario B where rerouting, we can see that the rerouting vehicles. Now let's run where rerouting the baseline scenario where in the baseline scenario, we do not have the rerouting. Let's run the scenario. Make delay a little bit more. I'm running the scenario. Now there is no incident. And all vehicle are moving same as scenario B and A same. But when incident will happen in the baseline scenario, all vehicle will queue up and pile up behind the incident vehicle or the block vehicle. We'll see. Maybe in the simulation, you can see that the incident near 800 or 900 seconds. We are waiting for the incident so that we can see the baseline situation. We are waiting. Here is the vehicle is almost stopped or slowed down, and all vehicle are queuing behind the breakdown vehicle, and no vehicle actually cannot reroute because they do not know. And now the queue is cleared, and all vehicle are moving in the regular motion. This is the baseline scenario, and previously I show you the original scenario. So that's it all about my actually the simulation. Let's go to the my presentation. So this is the scenario A where no rerouting of vehicle during incident, and this is the scenario B where rerouting of vehicle dynamically when incident occurs. So what is the dynamic Traci flow chart or flow diagram for my Traci code? Firstly, it will initialize the simulation, then run step-by-step simulation and check for the incident. When there is no incident, reroute logic will not actually trigger. But when uh, incident occurs, it will trigger and block the road, and reroute logic will be activated. And reroute logic will activated, and vehicle will travel to the alternative route and wait for the clearance. When the main line is clear, then no incident. If it's not clear, then again check for the incident. If it's clear, then reset everything and go to the next step. So this is the flow chart of my Traci code, where we have total 6 and 7 steps. First one is initialization, second one is step running, third one is incident check, fourth one is trigger incident and blocking by the breakdown vehicle. Fifth one is our reroute logic. Sixth one is checking for clear, whether the road is clear or not, and 7 1 is reset. And circulately this will again go through the circulation of the code. Next, I am writing out the pseudo code of my Traci incident. Firstly, what is in the code? If we look at the code, actually, I am a little bit making it smaller and describe the code. Let's describe the code. Let's describe the code side by side. I'm keeping the code and the pseudocode side by side to explain it properly. Firstly, the simulation will run the SUMO GUI. Here we can see that the simulation will run the SUMO GUI. Then there is two option, not two switch. One is to enable incident. It can be true or false. I am assigning true. And again, detouring the route, it can be true or false. For baseline scenario, detouring route is false. For our scenario B, the detour routing will be true. And we'll set the number of parameters. Our parameters are firstly the incident age, position, duration, and incident check start time. Also flow prefix, what is the traffic flow, and detour route will be assigned. Also ID of detectors and threshold value, which I have already talked about, that 50 is our 50% is our threshold value, and also some criteria parameters will make it true or false. That is incident active, incident cleared. We will check incident is active or not. Also check incident is cleared or not, and also check incident start time. It assigned to none, and block vehicle is created, which name is blocker here. Then what we did, we will this is the state variable. Actually, I'm talking about the state variable. After that is the function. Here we first print the network and print the network edge and detectors. Also configure the detectors, read lane and occupancy, and print if there is any errors. After that, main simulation loop, it will go through the main simulation loop and read the configured command and reroute, enable rerouting. If rerouting is enabled, and network detail will be printed. And in the loop, main loop, it will spec vehicle in the simulation and run the simulation step by step and get current simulation time in every step. After that, if incident is detected, if incident is detected, if incident is detected, it will check first incident is enable in my program is not. Then simulation will check about the simulation will also check about the check time, and incident also check whether incident is triggered or not, because if incident is enabled but actually incident will occur sometimes after the simulation run, so it will check. For each detector, it will read occupancy continuously and check for occupancy exceed threshold or not. If our incident is triggered, in that case, if our incident is triggered, in that case, it will activate the incident and start recording time and reduce the speed limit of incident to simulate or mimic our simulation. And after that, it will add a blocking vehicle in a specific position and stop is make it stop or very low speed, and this loop will going through. And for incident clearance, it will check firstly incident is active or not, and also check incident cleared or not. Then start time plus duration, it will measure the start time plus duration, and if incident is cleared, it will mark that it is cleared and then set the edge speed to default value and remove the blocking vehicle in the program run. And by this situation, for vehicle rerouting, it will check the detour routing is enabled or not. Also check incident is active or cleared or not. And for each vehicle, it will take the vehicle ID and reroute the vehicle. If the incident occurs, then it will detour those vehicle in a alternative path and record those vehicle which are detouring. So that's it about the main program. And lastly, in the main, finally, what we have to do, we have to connect Traci and print simulation is closed. That's it all about the pseudocode. And I am also showing my whole, I am also showing my whole program. Let's see. I am also showing my whole program Traci code side by side. We can see the side by side, and also GitHub link will be provided in the description box of the video. This is the original Traci code. Here, only one thing I changed between two scenarios, that is enable detour routing true for scenario B and false for scenario A. And I also described in my presentation regarding the pseudocode. And lastly, after generating the summary data from SUMO, we can make some comparative study. Scenario A, where our speed is almost 10. However, scenario B, average speed is little bit higher, 10.8, it goes to 11. And scenario B has almost 8.69% higher average speed than scenario A. Similarly, the average travel time in scenario A is 51.72, and in B, it is 45.05, almost 12.9%, almost 13% less in scenario B. We can see that that is rerouting. is advantageous. And we can see graphically that our average speed versus simulation time. The blue line is for scenario A, and the orange line is for scenario B, that is rerouting vehicle. We can see that in some situation near 8 to 900 second simulation, the average travel speed become very low in case of baseline scenario. However, it is not that much low. It's almost gain the average speed to original situation in case of rerouting vehicle. Similarly, if we look at the average travel time, we can see that the average travel time versus simulation, the blue line is and orange line is almost same up to 8 to 900 second simulation. However, when incident trigger, the scenario A produce more, require more average travel time. Those vehicles are slow down almost. However, in case of orange, that is in scenario B, we can see that the average travel time is not increased that much due to rerouting. And this the concluding remarks. Lastly, we can see that the dynamic routing of traffic during incident is actually advantageous. Using loop detectors, we can reduce travel time by 12.09% and increase average travel speed almost 8.7%, and comparing baseline situation and assigning the rerouting traffic. That's all about. Thank you so much for hearing my presentation. So this is my title of my presentation. Thank you.